Hello and welcome back. My name is Konstantin, and today we're going to solve a problem, a very cool problem: convert binary search tree to sorted doubly linked list. So we're given a binary search tree and we're asked to convert it to a circular doubly linked list. And they're kind enough to remind us how a doubly linked list looks like, where each node is connected to its left and to its right, and the first node is also connected to the last, and the last is also connected to the first. And we want to do this transformation in place. So how are we going to do this? How are we going to approach this problem? So let's go to this whiteboard and let's look at this tree first. And the first piece of information that they give us is that this is a binary search tree. So what do we know about that? We know that at every root value, all the values on the left are smaller than the root, and all the values on the right are greater than the root value, right? So this is the first piece of information that we need to use. Now, we also know that we have two ways to traverse a tree. We have a BFS and then we have a DFS. So what are we going to choose in this case? So if we dig a little deeper, we know that DFS is pre-order, post-order, and in order. And we know that if we traverse our tree with a DFS in order, and we're doing a binary search tree, our output is going to be a sorted list of elements, right? So our output will be 1, 2, 3, 4, and 5. So I guess this piece of information, you just have to do enough problems to be able to come up with, to know which DFS you should use. This is a binary search tree, so always keep in mind in order on a binary search tree will always give you a sorted output. So now if we look at this output right here and our elements in our linked list, how our elements should look like, it's very easy to see it's kind of like the same thing, right? So let's think about how we're going to solve this problem in place. So we know that we need to do a DFS in order. So with the DFS in order, we're just going to start from our root, right? And then we're going to go left, and then we're going to go left again. And then when there's no more left to go, we're going to go to the root, and then we're going to go to the right. So our DFS in order is left, and then it's root, and then it's right. This is the way it's visiting the nodes. So let's think about this. Let's have a node which is going to be our head. And this node, it's basically going to be returned at the end, right? So this is kind of like our result, or just let's call it head right now. And we know we need to have a node previous, right? Because it's not enough to link this 1 to 2, but we also need to link this 1 to 5, right? So we need to go left and right. So let's have another node which is gonna be previous, right? So previous is gonna be initialized to null at the beginning, right? So now we're gonna go through our DFS. So we're starting at the root, we're going left, 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 left. When there's no more left to process, we are doing some processing to this node right here, right? So what are we gonna do here? So we can check, is this previous, whatever we have so far, is this null? Because if this previous is equal to null, then we could just initialize our head to this element right here. So in this case, previous is null, so our head is gonna point to this 1 right here, right? The first value that we encounter right here. And then what we can do is move this previous to the head itself. So we're gonna move this previous to the head. So right now our previous is pointing to 1. And then we are getting out, we're process this node, so we're going to the root. So right now we're processing this node right here too, right? So we're making, again, the same check. We're checking, is previous equal to null? But this time previous is not equal to null anymore. Previous is equal to 1. So what we can do right now, we can link this previous to our, so we have access to 1 because this is our previous, and we have access to 2 because we are at 2 right now. We're visiting 2. So it's easy to say that previous.right is going to be equal to our root, and root.left is going to be equal to our previous. So you see what we did right here? We just linked them both together. And then we're going to move our previous. This was our previous right now. But then we're going to move our previous. We're going to shift it 1 to the right. So it's going to be our root. Previous is going to be equal to our root, and now it's going to be equal to 2. So now we keep doing exactly the same thing. Now we're going to 3. So checking again, is previous null? No, previous is equal to 2. So previous.right is going to be equal to our root. We're visiting 3 right now. And our root.left is going to be equal to previous. And then again, we're moving previous to the root. So previous is going to be 3. And it's easy to say then we're going to 4, right? So we're doing exactly the same thing. We're moving our previous, and then we're visiting 5. So again, we're visiting 5 right here. So once we made it to this 5 right here, here's like the interesting part. Not the interesting part, but there's another thing we need to do. So our previous is 5 right now, and our head is 1. But we said we need to link this together too. So our previous.right, it's going to be equal to our head, right? Just because we want to link them. And our head.left is going to be equal to our previous. So once we've done that, we have completed our total conversion of a binary search tree into a doubly linked list. And then all we have to do is just return this head right here. And then we visited all the nodes, and we're just returning our head, and then this will point to our new doubly linked list. So let's go ahead and code this problem super quick. So we said we need 2 nodes, right? So we know we need a private node, and we're gonna have a head, and then we also gonna have a private node previous, right? Previous. So, and we said we're gonna do this at DFS in order, right? So let's go ahead and create a method, and this method is gonna be a void, and we're gonna call it DFS in order, and we're just gonna take a tree node, or actually a node in this case, which is gonna be our root, right? So classic DFS, we know that if root is not equal to null, we have to do 2 things, right? Or 3 things. So we're gonna call our DFS in order on root.left. So we're going all the way left, and then we're gonna do some processing, and then we're gonna call our DFS in order on root.right. So right here in the middle, we're gonna do some processing, right? So we said we need to check, is our previous equal to null? Because if previous is equal to null, as in the first instance, our head is gonna be equal to this value, the first one, right? So if our previous is equal to null as for the first time, we can set our head equal to our root. So in this case, our head is equal to 1. Else, if for all the other scenarios, what we can do now is we're doing right now is we're link them together, right? So else, our previous.right is going to be equal to our root, and our root.left is going to be equal to our previous. And then all we have to do after that is just move our previous to the root. So previous equal root. So remember, we're moving our previous every single time 1 over to the right. So that corresponds to our root, because we're always going to visit 1 root to the right, 1 node to the right. So after we've done this, we're calling this method. So we could, in our main method right here, we could have a simple check. If our root is equal to null, then we could just return null because we have no tree, right? So then we can call our method. We can call our DFS in order, and then we're gonna pass our root. So now we said there are two steps that we're missing, right? We need to link our previous to the head and then our head to the previous. So how are we gonna do this? So we're gonna do this simply by saying previous.right is equal head, and head.left is equal to previous. And now all we have to do is just return this head. We had this reference to the head, so all we have to do is just return head. Return head. So basically that's it for this problem. Let's give it a try. It works, so let's submit. Yeah, it works. So that's it for this problem. If you have any questions or comments, please write them in the comment section below. And thanks for watching, and don't forget, if they have any problem, we've got a solution for them. So keep that in mind, and see you in the next video.